Good morning guys. Today's video is on another PS3, and this PS3 is from a commercial arcade game because this strip is attached for a token system kit. Here is red light. I am going to turn it on. There are 3 beeps and red blinking light. Again 3 beeps and red blinking light. So let's check for its faults and see how can we fix it. My God, hell of dust. I have to blow it. So much dust, I have to blow it again. Okay. So guys, as you heard 3 beeps and blinking red light as you've seen on the power strip. So first we have to check for the thermal circuit of this board because 3 beeps are related with the thermal section fault. Where is my, yes, it is here. So first try to check it from this thermal circuit. This thermal chip that gives data to the southbridge through this resistance, and this thermal chip gives thermal data to this southbridge through this resistance, and the input for these chips is these 2 resistances. These are at the value of 100 ohm. We must check it. So it is 100, and this one should also be at 100. Yes, it is. And this one is 47 ohm. 46.9. Yes, it's okay. Now let's check this one. 100 ohm, and this should also be at 100 ohm. Yes, and this one is 47 ohm. Yes, its mean thermal circuit is fine. So let's check for its power supplies first. For this I have to attach a ground here. Ground is attached here, and the power strip must be attached. And now jack for 12 volts and jack for standby volts. And now you can see here the red light. Yes, and Now turn my oscilloscope to analog mode. First sort out the wires. I have to sort out all the wires. Yes. Now it is now on analog mode. First, as you can see, the oscilloscope. Too much dust in Pakistan. I'm sure you can see it clearly. Now let's start, and we must start from this first power supply. This is for CPU. CPU's power supply choke. There are two chokes, 1 and 2, and we must check the oscillations on the input of these coils. Yes. It is different kind of oscillation, not proper, I'm sure. And here okay. Now check for the GPU. It is fine. Now check for the CPU RAM. Yes, it is, and output volt should be 1.8 volt. Sorry, it is 5 volt. This one is 1.8 volt. Here must be 1.8 volt. The 1.2 volt. Good. It is 12 volt are available, and now go for this choke. I will check the oscillation on this input point. Yes, and output is 1.8 volts, and here it is final choke, and here the volts must be 1.8 volt. Yes, so the power supplies are fine. If we want to check for the thermal data, is it running or not, we must check the thermal data on this resistance output. This gives thermal data to this south bridge. This is the resistance, 47 ohm value, and data is available on this resistance. Data is also available. Now check for the clock on the south bridge that comes from this Ethernet chip. Here it is the point, test point, this one. We must check the clock. Yes, clock is available, and this is the input point of clock to this Ethernet chip. It must be there because the output is available, so input must be there. Yes. So guys, powers are fine. The gates are also fine. No beep is good. Now check for the CPU by pressing. It's giving a slight pressure on this CPU. maybe some cracking in the balls underneath this processor. No. And as you can see that there is no yellow light, so this GPU is fine. It could not be there any fault. There should not be any fault related with GPU. This fault is only related with this southbridge, NOR and CPU. And now I have to check for the brick of this PS3. For this I have to ground the tri-state point, so we must check it. This one is the tri-state point, if I am not wrong. This one, yes it is. And if I check for this, it should be high, yes. Now I am going to ground it. I have grounded it. No, it is not bricked. There is some hardware problem and we must find it. Okay. For this, I will check for the FETs, the remaining FETs that are giving a sort of power supply to these, like this one. It should be 2.2K, 1.8, okay, 55, okay, and it is 1.7, okay. On the other hand, there is one more FET, this one. This is 2.2, yes, and this one is it is 2.2, yes, and it should be 99 or 55 ohm. 90 ohm, okay, it's fine. And no. What is wrong? And now we must check the clock distributor chip, this one. Around this chip there are some resistors that are at the value of 47 ohm, 33 ohm, 43 ohm, 43 ohm, 43 ohm. It should be 200 and 329 ohm, and this is for the 33 ohm, this is for 33 ohm, this one is 43 ohm. The resistors are fine. Now fuses must be fine. I need a motherboard of the same model to compare these readings. Well, first we try to give heat to this processor. Maybe there could be a sort of change or fault. If there would be a change in the fault, then the problem must be underneath this processor. First, we have to preheat the board so that it could not be bent. Afterward, we will concentrate on this chip. These are the steps for checking a motherboard. From the both sides we have to preheat it. Now I will concentrate on this chip. From the upper side, again we will go for the down side at the back side of this board. Now let's check it. If there would be a change, then there must be a problem underneath this chip. But no, there is no change. Should I let it cool down? Yes. No change. So horrible. It's horrible that I could not find the fault. Okay, no problem. So our fault relates with this southbridge NOR and this processor. So first I must check for the biasing of this south bridge. For this, it is here is a resistance that is at the value 6.8k. Yes, it is fine. And this one is 4.5k. It is fine. And these are the 10 ohm resistance. These are the coupling resistance from the Ethernet data. This is 10 ohm, this is 10 ohm, and this is also 10 ohm. Now come to these resistors. First, it is at the value of, it should be, I think, 47 ohm. Yes, it is. And this should be 4 point something kilo ohm, 4.6 kilo ohm. Yes, and it should be 33 ohm. Oh my god, it is showing 12 mega ohm. Yeah, that's the fault. First, I will try to reflow this resistors, and then we will check for the fault rectification. I think you can see it clearly here. This one is the resistor. It should be at 33 ohm, but it is in mega ohms. Horrible change in value. Oh my god, I have removed the resistor. Yes, now I will check it for its value. Now it is on 34 ohm, but we have to replace this resistance because it may change its value after heating up, and still it is not 33 ohm, it is 34 ohm. So let's check for the fault rectification. Or should I change it? I think I have to change it. Let's change it. There should not be any doubt of any kind. I have removed this resistor. There are many resistors of 33 ohm. I must take one from a donor board. I have taken out many parts from this board, and there must be a resistor of 33 ohm. 33 ohm resistance is like this. It is 31 ohm. Oh, 31 ohm. Should not be 31 ohm. Okay. Let's pick this resistance. we have to solder it properly with a good connectivity. I hope it is done. Now let's check for the display of our motherboard. I must put heat sinks. And this one power strip, and must connect HDD. And sure, I will connect HDMI cable because I am sure that the fault is rectified from this board. And here it is a 12 volts jack. Yes. And now you can see the red light at the standby. Now I'm going to turn it on. Oh no. Oh no. There must be another fault. First let me check for the value of this resistance. Yes, it is 33 ohm. And I must check for the connectivity. It is not connected well where it should connect. It is connected. It is going to southbridge. But I think it should connect via transistor. This connection is with this side pin. Yes, it is not connected. It is not connected. So try to resolder it with my iron. And we'll also use a heat gun. The connection was not proper, so that it is not in operating mode, so that it is not operational. Let's check it again. This connection is this. It should be with this open point. Yes, now it is connected. Let's check it again. As you can see that it is on red light. I am going to turn it on. Oh my god, again there is some issue. Good morning guys. Today I am going to use a UART device that is helpful in extracting the syscon codes from its memory. I have never used this device before, and I think that it is not as useful as it should be, so that I have never been used this device. But some of my followers were asking about it, and I decided to use it. Here is it, this device. It converts our data from the syscon IC to USB serial data. We need these three wires that are attached, the wires in white color, this one and this one and this one. Here you can see that the number one ground is simple ground. It should be attached with our motherboard so that we can read the data. Simple is that it should be connected with our motherboard, and 5 volts are not need to be attached because it will get 5 volt from this USB port, driver 5 volt. The next wire is TXT. TXT wire is connected with our syscon chip. It gives a data that is called transmit data. It gives signal to the syscon chip to read the data from syscon chip. And the third one and last is RXT. RXT wire is also connected. This wire is also connected with this our syscon chip, and it is connected on the syscon RXD pin so that it can read. RXD mean read data, TXT mean transmit data. So guys, let's start to use this device, and here you can see it is a simple device that converts our TXT and RXD data into USB data, serial data, and this chip is attached here. And as I can see that there is no converter, voltage converter installed on it. It means this chip is driven with 5 volts. So let's start using this device. It is called UART. Okay, this one I connected for the ground, and this is RXT and TXT pins points, and the wires are attached here, TXT, RXT and TXT. So guys, when I will turn my PS3 on for standby volts, yes, there is a light. And now I will put it in my computer. And as you can hear the connectivity. So guys, I will start the process. The code I have extracted from the syscon chip, it is a single code. All the 20 codes are only one, and here we will find the reason for this code. So here is the code, this one A080, no, yes, this one
003010. It says according to this code it is BE initialization. It means that the cell processor, the cell broadband engine, cell BE means cell broadband engine, is not initializing. Initializing means that the address data, the first address data that should be on CPU from the southbridge, it is not there, it is not initializing it, or BE power good, or the power for the CPU for the cell BE, cell broadband engine, is not good. And on the other hand, it says clock errors. These clocks are not clocks from some oscillator, but these clocks are from the buck controller chip. This buck controller chip gives the oscillations to the FETs to make a sequential buck amplification for the choke or near the cell processor, and the output from the choke, it should be 1 volt. So I have checked all of these things already, and there is no malfunctionings in any of one component, and there is no reason that it is not working. So I have to do some more work on this board. Let's see.
But now, because I don't believe the codes that are extracted by Syscon chip, we should, but it could not be 100% accurate. If there is some kind of device error or device failure, so first I will try to change this south bridge, because this CPU is not initializing. Initializing means the first bit that initialize it's this processor or its data that will come from the south bridge. So even the processing is not here, it is not communicating with the south bridge. That is also one of the reasons that I must change this south bridge. Okay, let's try it. And now everything is set, and let's try it again. Six beeps mean it is overheating. So we will check it out after fixing it on its fan and heatsink assembly. So these beeps are of overheating, kind of CPU overheating. This cell B E processor is overheating. We need not to remove this HIS, this plate, heat spreading plate. Many technicians try to cut this silicone underneath this plate and try to remove it and then paste it again, and then we need not to do that. In my experience, there is another solution for this error, the overheat error. I will show you in this video. Let's try it. Here you can see that I have refreshed the paste on both the CPU and GPU. Let's put it back on its assembly. And the tip is that I will keep a ice cream spoon. It was like this, ice cream scoop. I will put it here and one for the GPU here. So it will help to press this processor to the IHS. By giving the pressure the CPU from the back side, it will help that the sensor of the CPU will connect with the IHS. So let's try it. And somehow slightly bend these. Yes. Power it on, and now I will power it on with the standby strip. Here it goes. A fly is disturbing me since very time. Yes, now it is stable, and here I can see the voice of this PS3, but there is no display. Yes, now I will connect the controller, and yes, O is yes. Yes, O is yes, and should be set later. Yes, and guys, that the problem is solved. As you can see that it was not a problem from cell B processor. Even the fan is also white. So goodbye. Thank you very much. Goodbye.